The next conic section we're going to be working with are parabolas. Now, parabolas on the surface seem pretty easy because we've seen it in Algebra 1, but actually in conic sections, it's one of the slightly trickier ones. So to make it a little bit easier, let's just do a real quick Algebra 1 review. So the first question I'm going to ask you is take a look at these pictures, these graphs. Which do you recognize from Algebra 1? Okay. You shouldn't recognize these two. It should be more of these guys here. Reason being is these two are not functions. In Algebra 1, we typically don't deal with that. Now let's talk about formulas. Of these two formulas, which one looks a little bit more familiar from Algebra 1? Hopefully you said it should be x that's squared and not the y variable that's not. Now we're going to use this to advantage. I'll refer to these as Algebra 1 parabolas, just like this one is an Algebra 1 graph or equation. And then these are, we'll call it Algebra 2 equations and graphs. Okay. So now that we have that, again, these are Algebra 1 graphs. So what I'm going to do is when I set this up, it should be the x variable that's squared. So it's going to be x minus some value squared equals, and here's where it gets just a little bit funny, 4 times this value that's p, and then this is y minus some value, okay? If it's an Algebra 2 picture or an Algebra 2 setup, then we have to set it up with the y variable that's squared, and the x is not, okay? Very similar to a circle, this is going to be h and k. H and k is the vertex or the tip of the parabola. So here is the vertex. Coordinates are h and k. Same thing for this one, but you do have to be careful. H and k, h always goes with the x, k always goes with the y. So again, here's my vertex in an Algebra 2 setup. Then the next thing we're going to talk about is this value here, p, okay? P is the only new thing that's really introduced. What is p? By definition, p is the distance from the vertex, which is this sort of like this middle point of your parabola, to something called a focus, okay? The focus is sort of like a dot inside the parabola that kind of pulls, or the parabola gravitates towards that. So the focus for this guy would be right here. So this is the focus above a smiling parabola. This is the focus for a frowny face parabola. In Algebra 2 graphs, the focus would be right here, and if it's opening to the left, the focus would be on the left, okay? P is the distance from here to here, or here, or here, or here, okay? P is also the distance from the vertex, that same point that we were talking about at the very beginning, to something called the directrix, okay? What is the directrix? The directrix is a line on the opposite side of the focus. So the focus is up here, then the directrix is down here. Focus is beneath the frowny face parabola, then the directrix is above that. If it's opening to the right, the focus is on the right, and then the directrix is on the left. If the focus is on the left, then the directrix is on the right. P is also the same distance from that vertex to that directrix. So the vertex is actually sort of like a midpoint between the focus and the directrix. And then the last thing is, how do you know if it's a smiley face or a frowny face or opening to the right or to the left? This is where I say the basic common sense comes in. If P is positive, that means you're a smiley face. A negative P, if P is less than 0, that means it's a frowny face. Same thing with this. If I move to the right, if I open to the right, usually when we move to the right, that's positive. And when we move to the left, or if the parabola is opening to the left, then P is negative. So P tells us a lot. The sign of P also tells us which way it's going, either up versus down or right versus left. It also gives us the distance from here to any one of these other critical points.